Hey, this is G from Outlier Automation. In this series, I'm going to be talking about cybersecurity in industrial automation. If you're like me, you might find some of the terminology confusing, especially if you don't have a background in IT. It is very important to understand, and it's important to understand where to get started as well. So in this series, I'm going to be talking about some of the tools that Siemens has for their ecosystem, which you can use in order to protect against common vulnerabilities in the industrial automation or logistics space. So let's get started. It is very obvious, like I just said, that in industrial automation, cybersecurity is critical. If you just look at some of the news that's been going on, it has been a very prime topic of conversation. There's been a lot of studies around different protocols, different technologies as to what vulnerabilities exist in our space. And you might have seen some major vendors where there was a vulnerability exposed. It's not without warrant. If you read the book Countdown to Zero Day, which was about Stuxnet, it was one of the very first major industrial attacks. It was very coordinated politically, but it did show the breadth of what could happen when you're applying an attack to technology. It's unlikely that in your facility that there's going to be some large coordinated attack, although it could be, there's always a risk for it. It's still very important to understand what the potential risks are. I thought that the study by Deloitte that was put out on cybersecurity for smart factories was important to look at because it put some numbers to it. In particular, I saw between 2017 and 2018, cybersecurity incidents increased by 3.5 times for ransomware, spoofing. Probably have heard of a manufacturing facility that has been subject to ransomware at this point. And some of the risks included unauthorized access, operational interruption, theft of IP, which can have a huge financial impact. There's even a risk that people could physically get hurt from a cybersecurity incident. So knowing all these details, this can definitely feel pretty scary. Fortunately, there has been technical discussions going on in the automation space. Specifically, IEC 62443 covers that in many different aspects, including even down to the level of what type of security needs to be on devices that are going into the space, like from a hardware perspective. And what the IAC standard specifically does is it really outlines a framework for how to think about security in industrial automation. So I kind of like to think of it like risk assessments and safety equipment, either in robotics or machinery, which I have a standard in. It's very similar, but obviously applies more to the cybersecurity space. So the first thing that it does is think about what are we protecting in the industrial automation space. First would be safety systems. If safety systems go down, that means that we can no longer protect the people that are operating the equipment. So that's a pretty obvious one. After protecting human people, then we want to protect the equipment itself and processes because we want to keep being able to make money. That means it needs to be able to run the equipment itself, but also the supporting systems around it. And I think this is an important one that maybe people don't always think about. We need to be able to enter data. We need to be able to collect data in order to know what set points to run, for example. There's MES systems, ERP systems, all of the systems that go into the manufacturing process that could be affected by a cybersecurity incident. First thing, we have to define kind of the boundaries, and then we need to think about what is the risk, both the impact of if it was not accessible or whatever the thing that we're protecting, if that was not accessible, but also what is the likelihood that this could happen and also the severity. For example, if this is a safety system that is protecting multiple people or even potentially the environment, like in a water treatment system, then that would be a very high severity and the likelihood could be varying. So there's a framework for quantifying what this risk is. Once this risk is assessed, what actions do we need to take in order to mitigate that risk? And the security framework of the IEC standard lays out that is essentially a triangle, the combination of people, processes, and technology. These all need to work together in order to actually mitigate the cybersecurity risk. What I'm going to be mostly talking about is the technology aspect, but do keep in mind, it is clear from the standard that these will not work well unless the people and process portion of it is also addressed. So it needs to be part of the culture and be front of mind when actually operating the equipment. Okay, so from the technology aspect, it lays out that there are foundational requirements that every aspect of a solution is going to have. There's 7 of them. I'm going to focus mostly on the first and second points: identification and authentication control and use control. Just know that any type of technology that will be applied to cybersecurity is essentially going to have one of these 7 things, one or multiple of these things. And in the first 2, that is really what is known as access control. What is access control? The way that I think about it is really in 3 different areas, or they kind of are combined together. So one is authentication, another is authorization, and the third is central management. So authentication is that you are really verifying that the person who is trying to log in is who they say they are. So for example, they have a password. Let's say it's Jim, who is an operator, really is Jim. And if it's Julie, who's an engineer, it's really Julie. Then authorization is what can Jim versus Julie do? So Jim was an operator, Julie is an engineer. They probably have different roles that they would do when it comes to a facility or even different pieces of equipment. The third is central management. This concept is kind of like, let's say you had 100 machines. Each single person is individually controlled on each machine. Let's say now one of the people actually leaves the facility and should no longer have access to these machines. Well, what you would have to do is go across to every single machine and remove their access. Or hopefully you don't have just like one password that everyone can can access each machine with, which I know is very common. So the central management aspect is very important because it allows you to make timely changes to updating the cybersecurity profiles and make sure that everything is up to date and actually makes sense. Siemens has kind of 2 products that really address the access control portion of this. They have similar names, which is a little bit confusing. They are to do different functionalities within this access control. So one is the user management component, which is UMC, and the other is user management and access control, which is UMAC. The important thing is that UMC, user management component, is really for the authentication and central management part, and UMAC is the authorization part. Okay, so let me show a little diagram in order to explain this better. Starting from the right-hand side, UMC is essentially a server that can live on like a Windows server or virtual server, and it is handling the authentication and central management part. Everyone's passwords, all of the access part, and you could actually connect it to like Windows Active Directory if you wanted to synchronize it with your corporate level credentials. The UMC can connect to different applications within the Siemens ecosystem, such as TIA Portal, WinCC Unified, and actual devices, or Cinema RC, which are security appliances. The important thing here is that really what you want to do is actually have the authorization on that device or application level. Like I mentioned earlier, you might have different people, or say different operators or engineers, that can do different things, such as like access safety, change ladder logic, or even read code, but that could also be different between machines as well. Having the authorization on the device side is actually important because it allows you more flexibility into actually doing what you want, and having that on the server side would actually be pretty restrictive. So this is why there's 2 different products. And what I'll be doing is actually going into this more as an example using this in AWS, which I will be setting up the UMC server in EC2 on a virtual private cloud. And I will be able to talk back and forth to TIA Portal, the WinCC development environment, and then actually connect and secure this on the physical device side through a VPN connection. I'm pretty excited to show how to use this, and I hope it can give you some ideas as to how to start to implement better cybersecurity in your automated equipment and in your facilities. Please check out my next videos, and if you like this content, please subscribe.